In this question, we have forces F1 and F2 are unknown, and we have an equilibrium equation here. So first, step number one is we need to resolve the forces into their x and y components, and after that we'll apply the equilibrium equation. So to start, we have to first of all resolve F1 into x component, and this will be F1x, and y component, and this will be F1y, and then the F4 into x component, and this is the y component, and we'll name them. This is F4y, this is F4x, and same thing goes for F3. This is the x component, it's called F3x, and this is the F3y. Of course, F2 doesn't have any x component because it is vertical. So step number two is we need to apply the equilibrium equations, and these equilibrium equations, as we know, they are sum of all forces in x direction equal to 0, and sum of all forces in y direction is equal to 0. So this is equation 1, and this is equation number 2. So as it is obvious from the question, we have all of these elements that we need to add, and we have only these two equations to use, and we have two unknowns, so this should be sufficient from mathematical point of view. Now, which equation shall we start with should be explored here, and let us see. If we use all forces in the x direction equal to 0, we will have one unknown, and the second unknown will not be involved because this is the second unknown, so meaning that I get an equation that has only one unknown. That is good. But if you use sum of all forces in y direction equal to 0, this component will be involved, which is unknown, and this force is unknown also, so we'll have an equation that has two unknowns. That's why it is better to use the sum of all forces in x direction equal to 0. So now that we know what our plan will be, we need to do the calculation for the values of f1x, and f1y, and so on and so forth. Of course, f1x is the cosine of angle 30, because this angle is equal to this angle, so this is 30 actually. So it will be f1x will be f1, we don't know the value of f1, multiplied by cosine 30 degrees, and this is equal to 0.866 f1. f1y is equal to, again, f1 is unknown, multiplied by sine 30 degrees, and that is equal to 0.5 f1. That is for the f force. And for the f3, because f2 doesn't need to be worked on, so f3 will be the next. So f3x, we have the value for f3, so we will use that immediately, which is 800 pounds cosine 30 degrees, and that is equal to 692.8 pounds. And for f3y, again, the force is given, which is 800 pounds, and it is the sine of 30 degrees, which will be equal to 400 pounds. Now for f4, again, same story, because f4 is already given, so f4x is equal to f4, which is given us 4,000 pounds cosine 60 degrees, because this is the angle 60, and that is equal to 2,000 pounds. And for f4y, it will be again equal to 4,000 pounds given, multiplied by sine of 60 degrees, and that is equal to 3,464 pounds. So now we have all the values for these forces, and we can update our sketch with these values. That would be a good idea. So for F1x is equal to 0.866, that is F1, and for F1y is equal to 0.5 F1, and for F3x is equal to 692, and for F3y is equal to 400, and for F4x I would say is equal to 2000, and for F4y is equal to 3,464 pounds. Now that we have the values here, all we need to do is apply these two equations. So to apply these equations for all forces in the x direction, as we suggested, because that will give you an equation that has only one unknown. For x we'll have plus, we'll take this force, plus f1x, and this is minus f4x, and this is minus f3x, and these are only three forces in the x direction is equal to 0, so f1x is equal to 0.866 f1, minus f4x is equal to minus 2000, and minus f3x is equal to 692.8 is equal to 0, and from this equation we get the value of F1 is equal to 3,018 pounds. Now that we calculated the value of F1, now we'll continue to calculate the value of F2. To do that, we'll need to use the sum of all forces in the y direction, because we use the first one. So the second one, which was sum of all forces in y direction is equal to 0, and for that one we'll have all components in the y direction, we'll sum them up. So we're starting with F1, it is F1y is downwards, as you see, so we'll use minus F1y, and for F4y is upward, so it is plus F4y, and F2 is downward, so minus F2, and F3 is downward, so minus F3y is equal to 0. So again we have the values for these components. So for F1y is equal to minus 0.5 F1, because we calculate the value of F1, we'll multiply that one, and then we have F4y is equal to 3,464 pounds, and F2 is unknown, that's what we're trying to calculate, and for F3y is equal to 400 is equal to 0. So here we just substitute minus 0.5 multiplied by F1 is here, from here is equal to 3,108, and plus 3,464 minus 400 is equal to F2, and F2 is equal to 1,510 pounds, and this is the answer for this question.